Hi, this is a DAC Light presentation for Signals and Systems done by Aisha, Matt and Fatma. So Matt is going to start this presentation by talking about the square.
So this code is about sending a square wave to the DAC light and getting an output signal up, which is here. So we enter a resistor value and our capacitor value. As you can see from the graph, the capacitor is charging and discharging at 100 samples. We set that in the code, and to prove that the RC circuit is working, we took we took 100 samples over the sampling rate that we calculated that's appropriate to our time constant, and we got that equal to 0.9, and that's the value that we calculated by hand. And now Fatima will explain the calculations.
This is the calculation for the time constant, which is in the top. We just calculate the tau, which is R multiplied by C, and we got 0.18, and 5 tau is 0.9, and the sampling rate that we got just by dividing 100 over 5 tau, which we got 11111.
So now we will move on to our next test of the sinusoid. So this is a program which has all comments in it to explain itself. So this produces a sine wave to correspond with the sine waves that is produced from the DAC light. And at the bottom it does a few calculations as well, so I'll just finish. And the resistor value that we used in our circuit was these. So this is going to cost so I'm just going to run that again because we had a new. So this should create a 6 by 2 matrix. But okay, so this is now completed, and here you can see the calculations made for the equal voltage in Cartesian, the modulus, and theta degree. And we will go to our plots. So the green is the IP taken from the RC circuit, and the red is the synthesized sine wave. The first one has the lowest sine wave, and as it goes on, it increases, the frequencies increase, which is set by the code. and the max amplitude of the red does not exceed 255. So at this, so Matt is going to explain the second thing.
On the right hand side of the plot is the segments that we took from the alpha signal, which is this. And on the code, we want to calculate the amplitude of this. So we took the max of it and the minimum of it and take that away and divide it by 2 to get the amplitude of each one. And from the code, that's actually equal to what we actually calculated. Farmer will now explain the calculations.
And this is the calculation for the frequency response, which we got from this resistance and C and F, which we use these numbers, and we got this H as a 0.0088 by this angle minus 89.5, and V in which we use this equation, and then from this response we got this as output, which shows the amplitude is changed, and then the phase, which is we got minus 89.5, and then the frequency is the same. This all is in this project.